What's going on, everybody? Got another video here for you. This one's differential equations. It's higher order homogeneous equations. So let's get started. So this video here is going to actually relate to the next video that I'm going to post, and the video that this goes with is going to be called auxiliary equations with repeated or complex roots. Okay, so they're similar. I mean, you could probably do it all in one section, but this book, it splits it up into two sections, so that's what I'm going to do. All right, so check that video out also. It's like it said, repeated roots and complex roots. This right here, these are all going to be unique roots. All right, so it says the general linear differential equation of the nth order is of this form right here, okay, where the a's and b are continuous functions of x, which may be constants, and this equation is termed linear since y and all of its derivatives appear to the first power only. All right, so this is just a naught times the nth derivative of y with respect to x all the way down to the first derivative, and then plus a sub n times y, and this equals b. And then we have, for convenience of notation, the nth derivative with respect to the independent variable will be denoted dn. Here d is called the operator. So basically what this book does is it'll write some of the differential equations we have to solve in this form, and then it will write some of them in this form right here. Okay, and this right here is just like this right here just means the first derivative, okay, of y. And if it has a 2 right here, that means it's the second derivative. All right, so it's just a simpler notation to write it in, and this book, it'll actually write it in this form, and it writes it in this form. It'll switch back and forth. So, and we'll work equations in both forms, and I mean they mean the same thing. It's just different notation. And if b is equal to 0, the general linear equation is called homogeneous, and if b is not equal to 0, it's called non-homogeneous. This section here, this video, is only going to deal with homogeneous equations. I will have a video later. I'll have another video you can check in the playlist. It'll be non-homogeneous. So here we have, this right here is going to explain to us how to solve these things. So it says second order homogeneous equations with constant coefficients. So a naught second derivative of y plus a1 times derivative of y plus a2 times y equals 0, where the a's are constant, has auxiliary equation a naught m squared plus a1m plus a2 equals 0. So the second derivative, that's going to be the m squared, the first derivative m, and this y here, that's going to be your constant. The general solution of this differential equation is y equals c1 e to the m1x plus c2 e to the m2x, where m1 and m2 are the solutions of this auxiliary equation here. Okay, so basically what we do is we find the auxiliary equation, which is easy to do, and we solve it. Typically we're going to factor, quadratic formula, or you can complete the square, something like that. And that's what's going to give you your m1 and m2. And then all you do is plug it into this formula here. You've got to know this. If you don't know this right here, then you can't work the problems. So you've got to know them. You've got to know that. All right. So let's solve this differential equation. So the first thing we want to do is we want to write our auxiliary. Whoop. I don't know what happened there. I'll close that out. I must have accidentally hit something. All right, so solve this differential equation. So we write the auxiliary equation, which is this, okay? So the auxiliary equation is going to be m squared, that's from this, minus m minus 2 equals 0, okay? And then we solve. So we got m minus 2 plus 1. So m minus 2 equals 0, or m plus 1 equals 0. So m equals 2, or m equals negative 1. And so now all we do is we plug it in, okay? We plug it into here. See, we solve for m1 and m2. And so we get y is equal to, all right, so look at this. See, C1, e raised to the m1, and that's going to be 2 times x, plus C2 e raised to the m2, which it's our negative 1, so negative x. And there's your solution. Now, look, which one do you call m1, which one do you call m2? It doesn't matter. Look, we could write y equals c1 e to the negative x plus c2 e to the 2x. Either one of them is correct, okay? It doesn't matter. So, you know, however you want to write it, doesn't matter. If you want to write the smaller solution first, you know, write the smaller one and work your way increasing, that's fine. If you want to write the largest one first and have them decreasing, that's fine too. All right, so let's look at this one. Okay, it's going to be the same thing. Let's get our auxiliary equation. So m squared minus 5m plus 6 equals 0. And so we solve this. So we factor. So that's going to be minus 3 minus 2. So that's one thing that you're going to have to know how to do, is you're going to have to know how to factor, which you should know how to do that by now. So m minus 3 equals 0, or m minus 2 equals 0. So I get m equals 3, or m equals 2. And then we just plug it in. So we get y equals c1 e to the m1. Let's go with the 2. Plus c2 e to the m2. We'll call that 3. And just write it. I'll write this one in increasing order. And so there's your solution. So you can see it's not difficult to do. It's really pretty easy. All right, so let's look at the next example. And we are going to do one that has a particular, we are going to find a particular solution to it on the last problem. All right, so look at this one. Well, now see how this one's written in a different form. We're using double prime and prime for our derivative, okay? See, this right here would be the same thing as if I wrote this. That would be the same thing. Okay. All right. So first thing we want to do, we got y double prime minus 6y prime equals 0. Let's get everything to one side, set it equal to 0. And so I've got m squared minus 6m equals 0. So m times m minus 6 equals 0. So m equals 0, or m minus 6 equals 0. So m equals 6. So we've got y equals c1, 0 times x, dummy, e to the 0 times x, plus c2, e to the 6 times x. And so that's going to give me y equals, now remember, this this right here is 1. That's e to 0 times x is 0, so e to the 0 is 1. 1 times c1 is c1 plus c2 e to the 6x. And there's your answer. Okay, that's what I was talking about. This video and the next video could have been done in one video, because I mean this one, you can see it doesn't take long. All right, so now once again, look, this right here is written in another form. This would be the same thing if we wrote it like this: 2d3y plus d2y minus 7dy equals 0. Okay, that would be the same thing. So let's write our auxiliary equation. So we've got 2m cubed plus m squared minus 7m equals 0. All right, so we're going to have, we'll have quite a few solutions here. So let's see, let's factor out an m. 2m squared plus m minus 7 equals 0. So I get m equals 0, or 2m squared plus m minus 7 equals 0. So I do get a solution of m equals 0. And so now I've got to solve this thing. Well, you notice here this doesn't factor. So we've got so we'll use the quadratic formula. So remember, minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So m is equal to -1 plus or minus the square root. Let's see what this is going to be. So that's going to be 1 plus, what is that, 28 times 2, 57. Square root of 57 over 4. All right, so now remember, these are two solutions right here. So let's write our solutions up here. So I've got m equals 0. I've got m equals -1 plus the square root of 57 over 4. And m equals -1 minus the square root of 57 over 4. And so I get y equals c1 e to the 0 times x plus c2 e to the, and which one do we want to write first? It doesn't matter. -1 plus square root of 57 over 4 times x plus c3 e to the -1 minus square root of 57 over 4 times x. And then, of course, this term here, once again, that's 1. And so I get y equals c1 plus c2 e raised to the -1 plus square root of 57 over 4 times x plus c3 e to the -1 minus square root of 57 over 4 times x. And there is our solution. Okay. All right, so this is the last example. And you can see it's a pretty short video here. Okay. All right, so solve the differential equation and find the particular solution that satisfies these conditions here. All right, so I've got d2y minus 2 dy minus 15y equals 0. All right, so this is what? M squared minus 2m minus 15 equals 0. So this will factor. So m minus 5 plus 3. So m minus 5 equals 0, or m plus 3 equals 0. So m equals 5, or m equals -3. All right. So we've got y is equal to c1 e to the 5x plus c2 e to the -3x. All right. Now, what does this right here say? Okay. So it's saying dy is equal to 2 and y is equal to -1 when x equals 0. So what exactly does that mean? Well, all that's saying is that y of 0 is -1. So when I plug 0 in for x, I should get -1 when I plug 0 in here. And then this one is saying if I plug 0 into the first derivative, I should get 2 as an answer. Okay, so when I plug 0 into the first derivative, I should get 2 as an answer. So we need to take the derivative of this. So I get y prime, let me change colors. So I get y prime is equal to, all right, C1. So the derivative of e to the 5x is e to the 5x times the derivative of the exponent. So the derivative of 5x is 5. And then I get C2, and then derivative of e to the -3x is e to the -3x times the derivative of the exponent. The derivative of -3x is -3. All right, so there's y prime. So what this is saying is y of 0 is equal to C1 e to the 5 times 0 plus C2 e to the -3 times 0, and that should equal -1. All right, so let's go ahead and just do the y prime also. So that's going to be 5C1 e to the 5 times 0 minus 3C2 e to the -3 times 0, and that should equal 2. Okay, see, that's what they gave us here in the problem. All right, so remember, this right here is 1, this is 1, this is 1, and this is 1. So I'm left with up here, notice this this equation I'm left with here, and I'm left with this equation here. So this tells me that C1 plus C2 is equal to -1. And this tells me that 5C1 minus 3C2 is equal to 2. So now I have a system of equations to solve. So let's see, to do that, I can multiply this by 3. So then when I add them, the C2s will go out. So that's going to give me 3C1 plus 3C2 equals -3. And then 5C1 minus 3C2 equals 2. And so that's going to give me 8C1 equals -1. So this tells me that C1 is -1/8. All right. And so now I can take this -1/8 and I'll plug it back into this one. So I get -1/8 plus C2 equals -1. So C2 is -1 plus 1/8. So C2 is -7/8. All right, so remember this right here, where is it? Right here. This is our solution. This is y. So I'm going to take that and I'm going to bring it down here so we can see it. All right, so there's my solution. That's y. And so now I'm just going to plug -1/8 in for C1 and -7/8 in for C2. So I get y equals -1/8 e to the 5x minus 7/8 e to the -3x. And there's my particular solution. All right. And so that's the video. I hope it all made sense. So it was a nice short one. Pretty easy stuff there. Remember, the next video is kind of like a part 2 to this one. So, check it out and it'll show you how to do. You notice how when we solve for m, all of the m's, they were unique. They were different. Well, we're fixing to do one where when you solve for m, they might be the same. You might get 2 roots that are the same, or you get complex root, imaginary solution. Alright, so I hope this helped. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I will see y'all in the next one. Later.